In the previous video, we've reminded ourselves that for an ordered pair to be considered a solution to an equation, the x-coordinate and the y-coordinate of the ordered pair, when substituted for x and y in the original equation, must produce a true statement. In this next example, we are given the equation y equals negative x squared plus 1. And we have a table of values with some x values already picked out for us. We need to compute the corresponding y values that would create ordered pairs that are solutions to the equation. To do this, we simply substitute the given x-coordinate into the equation and find what the corresponding y-coordinate would need to be. Let's start with x equals negative 3. When we substitute negative 3 in for x in the equation, we get y is equal to the opposite of negative 3 quantity squared plus 1. The use of grouping symbols is really important because if we don't use them properly, we can calculate incorrect values. Negative 3 when squared gives us a positive 9, the opposite of which is negative 9. Negative 9 plus 1 would give us negative 8. That means that the ordered pair negative 3, negative 8 is a solution to the given equation. Let's go ahead and graph this ordered pair on the graph here to the right. We have negative 3 for x, so that's 3 to the left of the origin, and then down 8 units because we have a negative 8 for the y-coordinate. So that is one of the solutions to this equation. Let's repeat this process with the remaining given x values. Negative 1, 0 is also a solution. Zero, 1. One, 0. 3, negative 8. Now, all 5 of these ordered pairs are solution to the equation, but there are many more solutions that we have not graphed yet. In fact, there's an infinite number of solutions to this equation. We're not going to be able to list them all in a table format because there's an uncountably infinite number of solutions. However, the solutions are going to form a curve that will pass through the given 5 points. In fact, quadratic equations have graphs that are called parabolas. Parabolas are these kind of U-shaped curves. In this case, this parabola opens down. In a future module, we'll see how we could have predicted that by looking at the sign of the leading coefficient. In this case, the leading coefficient is a negative 1. Next, let's review how to find the midpoint of a line segment. The midpoint of a line segment for which we know the coordinates of the 2 endpoints can be found with the following formula. We're simply going to find the mean of the 2 x-coordinates of the 2 endpoints, and then find the mean of the 2 y-coordinates for the 2 endpoints. Here, the word mean is a substitute for the more common word average. However, mean is the correct mathematical term, whereas average is a bit ambiguous. In the example below, we have that a line segment has endpoints at negative 4, negative 2, and 2, 5. To find the coordinates for the midpoint, we're going to use the formula above. In this case, negative 4 is acting like x sub 1. Negative 2 is acting like y sub 1. Basically, this is an xy pair where we use a 1 subscript to designate that this is the first of several points. In this case, 2 is our second x-coordinate, so we'll label it as x sub 2. And y is our second y-coordinate, so we'll label it as y sub 2. To find the midpoint of this segment, we are going to go ahead and add the 2 x-coordinates together and divide by 2. So negative 4 plus 2, and divide that by 2. And we're going to do the same thing with the y-coordinates. -2 plus 5, and then we're going to divide that by 2. The result is an ordered pair, so we're going to use the parentheses to enclose these two values. I use the capital letter M for midpoint. That is a common label. All right, let's take a look at the x-coordinate. -4 plus 2 is -2, and when divided by 2 will give us a -1. For the y-coordinate, we have -2 plus 5, that's 3. 3 divided by 2, we could write it as a decimal, but we could also leave it as an improper fraction, which is preferable in algebra. That means that the midpoint of this line segment is at the point -1, 3/2.